Hi, this is Mrs. Slater. Today we're going to talk about slope and a lot of things dealing with slope and geometric figures. One thing is going to be proofs. We're going to apply how to prove different things from algebra that you have seen before. And we're going to relate slope to pictures and geometric figures on a coordinate plane. And then we're also going to recognize and again review things about parallel and perpendicular lines. So when we go to the first one, you have to think of what could actually help us solve this problem. We know we can determine whether a triangle is a right triangle if we know that there's a right angle in it. And right angles, as we know, if right angles, then perpendicular. And perpendicular lines are going to be opposite reciprocal slope. So perpendicular lines have opposite reciprocal slopes. And so let's go ahead and fast forward down to the bottom of your page where it says slope, and just go ahead and review that formula. M would be the common variable used, and we're going to have the change in y over the change in x. Okay, so now we can apply that here, because if we can look at the certain points we have at 0, 4, and then at 1, 2, and 4, 6. Here is our triangle, and you can make your best guess to where maybe that right angle would be. So to me, my sketch of a drawing here, I would think that the right angle is right there, and then I'm going to see if it's a right angle. So if this one is at 0, 4, point A, and then point B was at 1, 2, and C was at 4, 6, and I'm going to try to find the slope of this line. Let me get a blue, this one, and then I'm also going to find the slope of this line. And the main part of all of these is being organized. So if I'm going to find the slope, I'm going to put M, meaning slope of AB. So if I ever have to come back to it, I know exactly what I have just found. So AB would be the y's 4 minus 2 over 0 minus 1. So that gives us a slope of 2 over negative 1 and negative 2. Okay, and then the next one that I believe would be a opposite reciprocal slope, I'm going to try that one also, again labeling it very well. So it's AC, so I'm going to put MAC. The slope of AC is going to be the change in y, so it's 6 minus 4 and 4 minus 0. So you end up with 2 over 4, and that is 1/2. So because those two are opposite reciprocal slope, we can say that yes, triangle ABC is a right angle because the slopes are opposite reciprocal. Okay, so we have a conclusion. We have just proved that we have a right triangle. Now let's say we didn't get that right angle to begin with. I would also check the other ones and to make sure that they're not opposite reciprocal, because you'd have to prove that they are not. But once we have one right triangle or one right angle, we know it has to be a right triangle. Alright, let's go on to the next one. We're trying to prove that points are collinear, and slope also is going to be very helpful here. If we know that the slope of these 3 points, we have one in quadrant 1, so it's all the way up here at 5, 10, and then 0, 4 is going to be down here on the y-axis. So that's B, and then 2, 2 is going to be right here. So you can see just from my sketch here, it's going to be very close. And we don't necessarily know unless we know that the slopes are the same. So let's go ahead and again label very well. Let's try slope of AC, and we'll see if this is going to be a certain slope, and then we'll compare it to the rest. So AC would start with 10 minus 2 and 5 minus 2 to give us 8 over 3. Sorry, that's supposed to be a 2. And then if I find the measure of the whole thing, like the measure of, not the measure of, but the slope of AB, then it would be negative 4 minus 10 and 0 minus 5, and we get negative 14 over negative 5. So what this tells me is because they're not the same slope, they cannot be on the same line. There's just no way possible. So to answer it, we would say it's not collinear because all points need to have same slope. Okay, so let's look at the next one, where it says find r so that the line passes through these 2 points with a slope of 1/4. We have this unknown, and it's kind of in a weird spot. But if you know the formula and you know what the slope is, it's just plug and chug. So I'd like you to pay attention to what the slope formula is. And really, what you have here is m is given. The first ordered pair would be y1, x1, and the second ordered pair is going to be x2, y2, meaning the second ordered pair. So when I plug all this information in for every variable that's missing, I end up with 5 minus 3 and r minus a negative 4. Okay, and then by cleaning that up, I want you to see if you can get the answer of r equaling 4. Alright, so let's go on to some more formulas that you have seen before and some of them you haven't seen. Midpoint is the center of 2 points, so you're going to divide it in half. So you take the x values, divided by 2, and it is an ordered pair. A midpoint would be an ordered pair. So then you'd have your y's also divided by 2. Okay, the distance formula is x2 minus x1 squared, and then y2 minus y1 squared. Order is important with slope and midpoint and distance, so make sure you are doing them the same order, like x2, x1, don't be switching that up. Okay, leave it as y2 minus y1. Okay, and then the new one that you're going to see today, I want to first show you something on the next page, but you do not have to write it down. I'm gonna show you something that will make this formula be a shortcut to something else. So here's what I want to show you. We have to find the length from a point to a line, because this is called distance from a point to a line. Okay, so we have to find what is in red in this picture. Okay, so right here. And as we know, the distance, the shortest path from point to a line is the perpendicular. So that is the first move that I'm going to make. Again, you do not have to write this down. I just want you to look to all the work you're going to have to do. So the perpendicular slope, then you're going to find the equation of that line. Okay, and then so we know that this line right here in red is y equals a negative 3/5 x plus 11/5. Now if we want to find this point right here, we're going to have to find the intersection. And how do we find the intersection? I use substitution. Some of you may have chose the RRF button in the calculator. I chose substitution, and I end up getting x equals a negative 3 and y equals 4. So now I can say that this yellow point is the intersection. And once we have 2 points, now I can follow the distance formula, which is to get an answer of square root of 34. Okay, so that process, it took me a good 2 or 3, 4, 5 minutes. So now I want you to show the new formula, which we'll write here, and then I'm going to show you how beneficial it will be to you when you're doing your work. So the distance from a point to a line is the absolute value of a times x1 plus b times y1 plus c, close your absolute value, all over square root of a squared plus b squared. Okay, so this will be for a point, x1, y1, so you're going to have a point, and your equation must be in standard form. ax plus by plus c equals 0. Okay, so let's go back to the previous problem, And if you just take a look at what I have underneath the shade here, we first have to transform our line into standard form. Okay, so that doesn't take too terribly long. That now is our A, B, and our C value. The 2, 1 is our x1, y1 value. And then after plugging it into the formula, you end up with the exact same thing, where it is the square root of 34. Okay, so I think you can compare the two of them and feel like, hey, I think I'm going to use that formula and save you a little bit of time. Very, very nice shortcut. Next, I want you to recall any of the forms that you already know. Push pause and see if you know them all. Check your answers and see how you did. Now let's apply them. Okay, so to do the first one, we're trying to write the equation of a line. That's what WEL will stand for, and you're going to see that throughout the worksheet, of the median. So here's our first geometric term that we'd have to apply. From A to BC. So we've got to know that the definition of median means it's going to be from the vertex to the opposite side's midpoint. So we want to find the equation of this line right here. So what are some things we need? Well, if it's going to the midpoint, we're going to need to know what the midpoint is, and then we can just apply the distance formula. So let's go ahead and begin. Again, make sure you keep everything organized. So if we're going to find the midpoint of segment BC, let's write it that way. And then when we find the midpoint, and if we need it again, we can always refer back to this. So we know they're going to both be divided by 2. We have the x values that are 5 plus 1, and the y values are 2 plus a negative 4, for a final midpoint of 3. And that is a 4, so then that would be a negative 1. So this point is at 3, negative 1. Now we will be able to find the slope of AM. So slope of AM is going to be the change in y over the change in x to give us negative 7 over 12. And then we can take that information and plug it into the point slope form, because that's what we're trying to find here. Okay, so with that being said, we can take either one of the points. Y minus a negative 1 would be y plus 1 equals a negative 7/12, and then x minus 3. Okay, so that's one of the point slope forms. Or you could also use the original point A, which is a negative 9/6, so it would be y minus 6 equals a negative 12, and then x minus 9. No, it would be plus 9. Those two negatives make a positive. So either one of those will work. All right, so let's move on. This one, we have the same exact point, same exact picture, and we're going to write the equation of the altitude from B to AC. B, and an altitude is going to be a perpendicular to the other side, and since right angles create perpendicular lines, we know there's opposite reciprocal slopes. So I would like to begin by finding out what the slope is of AC, so then I can figure out what the slope of my line would be. Go ahead and push pause and find. So since the slope of AC is negative 1, then the perpendicular slope for BN is going to be equal to a positive 1. So we're going to use that, and it's in slope-intercept form, so I'm going to go right to slope-intercept form. Y equals 1x plus b, and I know for sure that BN has to go through 5, 2, so I'm going to plug those values in for x and y, and get negative 3 as our y-intercept. So our final equation in slope-intercept form would be y equals 1x minus 3. Okay, so I want you to go ahead and try the next ones, and I'll give you the answers so you can see that they're correct. Check your following answers on 3, 4, 5, and then bring your questions to class.